Right, we will start now. Welcome back, everyone. Hope you had a really good week. Today, I've got something planned, something different planned for today. So usually, I would, create like a lesson on something. But in this case, I was really busy this week actually, and didn't have much time to actually come up with like an actual lesson plan. But so today, I just decided like we're just going to chill and we're gonna try to solve some 9 chapters contest problems. So hopefully, this will be pretty fun. I didn't choose like all of the contest problems from the 9 chapters contest. I just chose like 10 of them, which should like suit your level, and they're from increasing difficulty as well. So from part C to part E. So like that's how the 9 chapters contest works for grade 7 8s. Oh, we have more people joining. We add them to the attendance. We have Patrick. Sorry, I forgot who else just joined. Here, let me see. All right, Jerry. And, okay, I think that's it for now. Yeah, so today, if you just joined, we're going to solve some 9 chapters contest problems from the 2019 contest last year's. I don't think we'll be having this contest this year though. And usually it would be hosted around this time as well, like mid November to late November. So yeah. So I guess we can pretend to like simulate the contest or something. But it's only 10 questions that I chose, so let's try to solve them. Here's the first problem. So this is C2, part C, question 2 from the 2019 contest. The question states, an arithmetic sequence of numbers is as follows. So it goes from 1 to 7 to 13 to 19, and it goes on infinitely, where each pair of consecutive numbers has a common difference. What is the eighth number in this sequence? I'll give you guys a minute or so to take a look at it, so you can solve it by yourself as well. Does anyone know the answer like off the bat? If you have an answer, you can shout out. Um, let's see. Here, let me think about it. Um, 43 seems correct. No, who's joining? All right, principal, sorry. Hey, 金老师好. No. Okay. Yeah, the answer is 43. I can show you guys a algebraic way to solve this. So give me a sec. I forgot to open my canvas. Shoot, here we go. Shares tab. Okay, so to solve these kind of like pattern-like problems, we usually express the pattern with some kind of formula. Like you let n, so you can let a variable named n equal like the term number. So it's right down here. So term number is basically like where the number is like within the pattern. So I'll go back to the slide. So like 1 over here would be the first term number, 7 would be the second term number, 13 would be the third term number. So like n equals 1 for 1, n equals 2 for 7. Oh, sorry. N equals 2 for 7, n equals 3 for 13, n equals 4 for 19, and so on and so on. So that's what I'm trying to say, as n being the term number. Right here, back to the canvas. And so we're trying to express the pattern in terms of n. So like how do we get each number? Like we had 1, 7, 13, 19. How do we get those numbers in terms of n? So I'll write down the 7. Wait, yeah, 7. Sorry. Write down the pattern right here. So we want to find a relationship between n and each of these numbers. And remember that n increases as you go, as you go from go to higher numbers. So this is n equals 1. This is n equals 2. This is n is 3. N equals 4. And you want to find like a formula that relates these numbers together. And usually a way we do this is use function notation. So we can say fn. So fn represents your numbers over here. So 1, 7, 13, 19. Those represent your fn's. And then 1, 2, 3, 4 are your n's. So we want to find like formula for fn. Does anyone know what a formula for this would be? Yeah, 6n minus 5. And I'll show you guys how he got this. So you have to look up a common thing for patterns is that they usually they have a difference, and a lot of the times it's a constant difference. It actually mentions in the question too that the difference between consecutive numbers is constant. And the difference is 6. So you see that 7 minus 1 is 6, 13 minus 7 is 6, and 19 minus 13 is also equal to 6. So it means this common difference would be you'd put it in front of your n, like 6 times n. Right? And then just to get the number that you want, you can subtract or add by like a constant like that. So 6n minus 5. And then you can use this formula to get the other term, like any other term inside the pattern as well. And so a question asks for the 8th term, we can just substitute n equal to 8. Or we can write f of 8, just like that. And this is just 6 times 8 minus 5. 6 times 8 is 48. 48 subtract 5 gives you 43. And so that's how you get the answer, 43. Anyone have any questions? No questions? All right, let's move on to problem C6. So magic square below here is a grid with a property that every row, column, and main diagonal. So main diagonal is like from the top left corner to bottom right corner, top right corner to the bottom left corner. It can't be these smaller diagonals with only two squares. That's what main diagonal is. So every row, column, main diagonal has to sum to the same value. And so find the value of x is right here, in the partially constructed magic square below. I'll give you guys a minute or so to figure that out. It's kind of similar, yeah.